أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم.
Darwin proposed a single concept as his evolutionary mechanism: natural selection. The title of his book clearly reveals the importance he gave in this mechanism: the origin of species by means of natural selection.
Natural selection was a powerful idea. Physical variations that proved advantageous would be inherited by succeeding generations. Through this process, populations would be altered, and over time, fundamentally different organisms would arise without any form of intelligent guidance.
About the emergence of favorable traits, Darwin was deeply influenced by one of his contemporaries, the French biologist Lamarck.
The French biologist Jean-Baptiste Lamarck was the first person to give a detailed account of the theory of evolution. Lamarck's theory, which was later refuted, maintained that living beings evolved from one another variations over time.
Lamarck thought that living things passed their acquired traits to future generations.
This was a form of another mistaken belief called acquired inheritance. It holds that any changes a plant or animal undergoes in response to its environment are passed on to its offspring.
In Lamarck's view, giraffes evolved from deer-like creatures. Their necks extended from generation to generation as they tried to reach higher branches for food. Lamarck also believed that if the arms of the members of a family were cut off for generations, the babies would start to be born armless after a while. Darwin, who was quite influenced by these examples, came up with an even bolder claim. In The Origin of Species, he argued that some bears, while trying to hunt in water, evolved into whales. But both Lamarck and Darwin were wrong. The laws of inheritance, discovered by an Austrian botanist, Gregor Mendel, caused Lamarck's and Darwin's assertions to collapse.
It is not surprising that Darwin got heredity wrong. So did everyone else who tried to find an underlying pattern in a surface picture that seems so random and disorderly. But unbeknownst to Darwin or anyone else, someone was busy solving this great puzzle. In the process, he laid the groundwork for the new science of genetics.
In 1866, his research was published in a scientific journal and then sent to more than 120 libraries and universities. Mendel's discovery correctly described biological reality, and yet it carried a conspicuous flaw. It did not confirm the atheist spirit of the times. For example, Ernst Haeckel completely dismissed Mendel's work, and he endeavored instead to substantiate the theory of evolution and elevated the false ideas about heredity based on the ideas of Lamarck to the status of a law. Today, false beliefs about the inheritance of acquired characters are attributed solely to Haeckel, but Darwin too was wrong.
The science of genetics that developed at the beginning of the 20th century, that it was not acquired physical traits, but only genes that were transmitted to subsequent generations. This discovery made it clear that a scenario suggesting that acquired traits accumulated from generation to generation and generated different living species was implausible. In other words, there were no inheritable variations for Darwin's proposed mechanism of natural selection to choose from. Subsequently, the theory of evolution as advanced by Darwin has been collapsed early in the 20th century. All the other efforts by evolutionists in the 20th century could do nothing but only confirm that natural selection had no evolutionary power.
Genetic pioneers like Carl Correns and Niels Heribert Nielsen repeatedly emphasized that selection alone doesn't create something new. It only acts as a filter, like a sieve. Just as a sieve doesn't create new tea leaves, selection doesn't create new forms of life or new species.
Natural selection is a real process, and it works well for explaining certain limited kinds of variation, small-scale change. We have lots of examples of that, in fact. Where it doesn't work well is explaining what Darwin thought it could, namely the real complexity of life. We have the finch beak, and then you've got the finch itself. A minor change in the structure of the beak versus the origin itself. These are different scales of phenomena. These are different kinds of problems. And the important problem for biology is to understand where natural selection works and where it doesn't, and why there's a difference.
Evolutionist Roger Lewin has a much more credible take on this subject. Natural selection, as the central characteristic of neo-Darwinism, can have a stabilizing effect, but does not provide the creation of new species. It is not the creative force that many have suggested.
A famous evolutionist, the English paleontologist Colin Patterson, admitted this when he said, "No one has ever produced a species by mechanisms of natural selection. No one has ever got near it, and most of the current argument in neo-Darwinism is about this question." When it was clear that the mechanism of natural selection proposed by Darwin had no evolutionary power, evolutionists had to make a fundamental change in the theory. In addition to the concept of natural selection, they added a second mechanism called mutation. Mutations are alterations or distortions that take place in the DNA of living beings, mostly as a result of external effects such as radiation or chemical action. The theory of evolution now holds that living things are differentiated from one another and develop as a result of mutations.
One of the best known examples of a mutation affecting morphology is the four-winged fruit fly.
In opening a biology text, one will often see a picture of a four-winged fruit fly. Now, as we know, ordinary fruit flies have only two wings. The four-winged fruit fly has not only its regular set of wings, but a second set of wings just next to that. And the caption or the text will say, this is evidence for the process of evolution, that mutations affect the process of development, and you can get anomalies as interesting as a four-winged fruit fly. Well, it turns out that the four-winged fruit fly is actually a very poor example of Darwinian evolution, certainly.
There are no muscles attached to it, so the second set of wings is effectively dead. The fly is a hopeless cripple. It's kind of like having a small plane with an extra pair of wings tied to its tail. The fly can only survive in the laboratory, and it would be selected out by natural selection in the wild. So it's not a step forward in evolution. It's an evolutionary dead end. And it turns out that all morphological mutations that we know of are either have no effect on the organism at all, no fitness effect, or they're harmful.
Mutations are harmful. They can bring about small adjustments in a particular species, but no way are they able to change one kind of creature into another.
What about mutations and other genetic alterations are cited as the mechanisms used by evolution to add genetic information? Problem, they don't. Okay? Mutations lead to a loss of genetic information.
All examples of mutations are actually loss of information, even the favourable ones. There is no new genetic information. Claimed examples of evolution in action are actually examples of variation within a kind. Antibiotic resistance, insecticide resistance, peppered moths, all these are examples of rearrangement of existing genetic information or loss of genetic information. There's no new genetic information.
So clearly, if you accept that DNA model, that DNA is responsible for coding in some way all the characteristics of an organism, whether as recipe or as blueprint, then obviously you've got the basis of a theory of evolution, a scientific theory. Changes in the DNA produces changes in the organisms, etc. Everything flows from there. And yet, an unknown secret here, that neo-Darwinian paradigm has been known to be false, unquestionably false, irrefutably false, for over 50 years. I'd say the decisive year when the evidence became overwhelming was 1954. when a guy called Tracy Sonneborn published his final paper in his research after about 20 years of research.
The information required for large-scale evolution can really not come from random mutations. The Darwinian model says that it does, but nobody has ever made a calculation to show that it does. I've made a calculation that shows that it doesn't. It's very improbable that there can be many small steps of evolution, many small changes adding up to one large change. And not only is it improbable on the mathematical level, that is theoretically, but experimentally one has not found a single mutation that one can point at that actually adds information. In fact, every beneficial mutation that I have seen reduces the information, it loses information.
Can you give an example of a genetic mutation or an evolutionary process which can be seen to increase the information in the genome?